Sure. All right, guys, we are ready to get started. Welcome to RITSec Week 8. Make sure you guys join the Discord if you haven't, if you are new. I could hold the slide up for a second. Seems like we're all good. All right, sign-in is dropped. Please sign in, guys. We will have pizza today, and we will be checking to make sure you guys signed in. All right, check the calendar. It is being updated. Check out the RITSec mailing list as well. Now clap it up for the sponsors, guys. Clap it up for the sponsors. All right, thank you guys. Follow our social media. We're streaming on YouTube. Now for announcements. If you guys did a co-op this summer, scan this QR code. Good information for us. There is a WESIS general meeting happening on October 20th at 4 o'clock in the conference room, so I'm pretty sure it's 2730, featuring Alan Torrance, who's the executive director at JP Morgan. And he will be discussing career tips, AI at JP Morgan, and his journey and lessons learned. And now for Cloud Security by Lucas Frink.
Alrighty.
All you.
Hey guys, how's everyone doing?
Good.
Awesome. I'm pretty good. A little tired. Getting things started though. It's the end of the week. So a quick little intro. I am a 5th year cybersecurity student. This is my last semester here. I play a little soccer. Okay. I play a little soccer. There's a couple pictures. That's me in Central Park next to the Balto statue. Me on the way back from work. And then I had a chance to go to the One Piece Cafe in California this summer. So that was pretty fun. What we're going to be talking about today is we're going to be talking about what is the cloud, why would you choose the cloud model and some concepts, cloud services, how to access the cloud, network security groups and firewalls, IAM and KMS, and some cloud threats. And I got a little bit of a cloud threat demo for you guys, so we will get to that. So what is the cloud? It is not just a cloud in the sky. You're going to be thinking more like a big data center hosted by big companies like Amazon, Microsoft, Google. They have all the hardware. You are just using their hardware to provision instances, provision services, things of that sort. You're shifting more from an on-prem infrastructure to a virtualized infrastructure. And the responsibility of that infrastructure is shifted from the from you being the on-prem people to more of Amazon, Microsoft, and Google. So why would you choose the cloud? The big thing that they want to get across is that they have reliability, availability, consistency, transparency, and efficiency. Reliability is how reliable their services are. So their operation without failure. This is why you see things like service level agreements where they talk about 99.999% uptime. And if you do the calculation, that comes out to be like minutes of downtime per year, which is absolutely crazy. Availability, this is like how accessible and operational the services are if things do go wrong. Consistency, so if I log into my AWS instance in Rochester and someone logs in California, you're not going to have any real changes to the data. You both are seeing pretty much the same thing. Transparency is how complex the system is and how much that is obfuscated from the user. And efficiency is maximizing the performance. This is things like scaling, how resource allocation gets across your services. There's 2 different types of scaling. You're going to have vertical scaling and horizontal scaling. Vertical scaling is going to be talking about, so I have one instance and you're going to provision more resources for that specific instance. Horizontal scaling, this is when you have multiple instances or one instance that gets spread out across multiple instances. So you spin up more services just to deal with a specific load. So a couple different cloud models that you guys are going to hear are private cloud, public cloud, hybrid cloud, and multi-cloud. Private cloud is like, this is more like a dedicated environment for organizations. This is when you don't want your data touching any other customer's data. Think classified information, think stuff that governments would operate on. Public cloud, this is when multiple different organizations are dealing with like the cloud hardware. So if a bunch of different people in this room spun up AWS instances, we could be using the same hardware. It's just dependent on like how those resources are allocated. Hybrid cloud, this is when you have on-prem infrastructure and cloud infrastructure. I've seen this happen a lot with Active Directory setup. Azure actually has a built-in function called Azure Arc where you can sync an on-prem Active Directory network to something that is to your cloud Active Directory deployment. It's called Entra ID on the cloud. Multi-cloud, this is when you're dealing with multiple different cloud providers. So you have AWS, Google, Azure, all working in tandem. I have seen 3 cloud providers be put into use, but it adds a level of complexity that even the people running the network don't necessarily understand everything about it. So best practice, stick to 1 or 2. And usually this happens if you buy services in one cloud provider and then you buy services in another cloud provider and you want to use those 2 different services. But most of the time, if you have a service in one cloud provider, there's most likely an equivalent in another cloud provider. So you try and keep it as not as complex as possible. So a couple cloud concepts we're going to be talking about. You have compute, storage, networking, and security. Compute, that's what's actually going to be running your applications. This is how you provide processing power for your apps. This is virtual machines, containers, serverless functions, and they operate on a pay-as-you-go model. So how much resources you are using, that determines how much you guys are going to be paying for your resources. Be careful, you can rack up a lot of expenses. It is very possible, and it is very easy too. Storage, this is going to be holding your data, so it's accessible anywhere. You're going to store files. This is like databases, backups, or logs. There's a couple different types of storage. So you have object storage, block storage, and file storage. Object storage, this is like for files, images, backups. Block storage, this is virtual hard drives. File storage for shared access. If any of you have taken like sysadmin, you guys have set up a file share. Similar premise. Networking, this is going to connect all of your cloud resources efficiently, and it controls how data travels between users, apps, and cloud services. So think of VPC, which is a virtual private cloud. This is still operating in the public cloud, but it's an isolated network. VNets as well, subnets, load balancers. Load balancers is basically saying you have a bunch of traffic heading into your service, so you're going to direct it in a way that it's not going to cause something to crash. VPNs and gateways. There's also security. So this is what's going to protect your data, applications, and infrastructure. When it comes to security, though, there is something called a shared responsibility model. The shared responsibility model basically determines how much responsibility you as a user of the cloud environment hold over what is in your cloud. So the cloud provider secures the entire cloud while you secure what is in your cloud. Think IAM, so this is Identity and Access Management, KMS, and monitoring and logging. So the big 3 that you guys are going to be hearing when you talk about cloud is platform as a service, infrastructure as a service, and software as a service. These are different cloud computing services that are offered at different levels of abstraction. And depending on which service you use, the cloud provider manages the responsibility shifts between what the cloud provider manages versus how much you actually control. So platform as a service, this is more of a managed platform where devs can focus on writing code, what kind of data goes into it. You're not managing the servers and apps necessarily, but the provider manages the infrastructure, OS, runtime, and patching. Infrastructure as a service, this is your virtual machines, storage, and networking. You control operating systems, applications, and configurations. Um, you kind of have the most control over infrastructure as a service when you're using a cloud provider. Think of it like renting an apartment. You bring the furniture and decide how you want to set it up. Software as a service. This is a complete package. You are buying a product and you actively deploy it on your cloud environment. So you're just using the app. The provider handles pretty much everything else. So the way I like to look at it is like cooking a pizza. On premise, you're cooking pizza at home. You have all the ingredients, you have the oven, you bake it yourself. When you shift to something like infrastructure as a service, you're cooking in someone else's kitchen. So you go to Domino's and you cook there. You use their tools, you use all their infrastructure. Platform, you customize a half prep pizza. You already have the dough, sauce, cheese, and then you just kind of put on the toppings. Software as a service, pizza delivered directly to your door. So next up, accessing the cloud. So you have a couple different ways you can access the cloud: web portals, CLIs, and APIs. So web portals, this is the most basic and what I would say you have a lot of control over, and it's not super complex. So you have an AWS Management Console, Azure Portal, and Google Cloud Console. You would log in as a user or using your root user email. And there are also CLIs. These are command line interfaces that you download to actually interact with your cloud environment. Major cloud providers all have a CLI tool. Most things you can do in the web portals, like the management console, you can do in the CLI. It just requires a little bit more tweaking. In the security with those, you have authentication, authorization, encryption, and auditing. So the authentication comes with your password, IAM, or API key. I didn't mention this, so APIs, this is like if your code wants to interact with your cloud environment, you would use APIs to actually communicate with your cloud environment. Authorization, so is the user you're logging in as, what permissions do they have, and what type of policies are set in place on your environment, like can you create or destroy instances, things of that sort. And encryption, TLS and HTTPS. Auditing, who's logging in and when. I got a quick little demo actually to show you guys of a AWS console we can actually look at. Okay, actually, we'll go through it later. Sorry, guys. So next up, we're gonna have network security groups. This is gonna be how your traffic flows throughout your infrastructure. Think ports, protocols, and actions. It's filtering traffic. It's not necessarily a firewall and pertains mainly to the resource you are applying it to. So you have a source IP, destination IP, port, and protocol, and then you allow or deny it. Best practices: incorporate an implicit deny. You want to have principle of least privilege, and principle of least privilege is the best way to go about setting up a network security group. So firewalls, this is going to be your first line of defense. This is protecting the perimeter. Filters traffic between trusted and untrusted zones. You have different types of firewalls. You have a network firewall, application firewall, and a next-gen firewall. Next-gen firewall is somewhat of a new concept. It adds like IDS, IPS type capability to your firewall. Network firewall, that's operating at your layer 3, 4 IPs, things of that sort. Application firewall, this is to prevent like known attack vectors against your web app of that sort. A couple types of firewalls. So AWS has Firewall Manager, Network Firewall, and web application firewall. Azure has Azure firewall and a web application firewall. These firewalls are software based, so they're managed by the provider and they scale automatically, and they integrate with your services that are running in the cloud. So network security groups versus firewalls. Network security groups focus more on the resource rather than the entire cloud infrastructure. Network security groups are lightweight. Firewalls provide like deeper and centralized inspection against external threats. You're going to want to use both if you set up infrastructure on the cloud. These tools work in tandem with each other to provide layered security. This is a term you're going to hear a lot: layered security, defense in depth, things of that sort. Next up, you're going to have IAM. This is your authorization mechanism. This is your identity and access management. Users, groups, roles, things of that sort. Prevents unauthorized access, prevents like unauthorized creation of services on your, anything you do on the cloud is going to go through IAM most of the time. Are you allowed to do this? Enforces principles of least privilege and make sure everything you're doing on your AWS or GCP or Azure is allowed. One second, guys. Trying to get the demo going one more time.
Did you try to share something?
Okay, I got it. Sweet. Okay, so this is a quick little demo of what an AWS console home would look like. So as you can see, what I was trying to show you guys earlier is the region we are in is the US East 2. And what's interesting about these regions is that they have something called availability zones. This is to allow for redundancy in case things go wrong in one place, another availability zone can kick in. They're still in the same region though, but they are physically separate data centers within that region. So when we're looking at IAM, so I have one user group right here, and the permissions set for this user group are going to be these permissions. And the reason I have these set up is because I use Terraform on this AWS environment, and I need to have a user that has the necessary permissions to actually interact with my environment, create resources. So if we check, these are the default permissions that allow that to happen. Look at IAM, see one user, and then whenever you create a user, you assign that role to it. You can assign them like single-handedly, saying like, okay, this user has this permission, but it's better to define roles. Another thing that I wanted to go over is you guys, this access key right here. Whenever you're using a CLI and you want to specify a user, you want to use an access key, and when you configure that access key on your system, there's going to be an access key and a secret access key. These credentials are actually stored in your user's home directory. It's a hidden directory. I don't know if it's different for other cloud providers, but I know for AWS, it's a hidden directory called AWS and has credentials that specify that user. Okay. So next up, we're going to be talking about a KMS. This is how you control your encryption on your environment at rest and in transit. In transit, you're managing your encryption keys this way, and provides you the possibility for envelope encryption. So you have data keys that actually encrypt your data, while you have a key encryption key that encrypts all your keys. You should be constantly rotating your keys, so this provides an easy mechanism to actually rotate your keys. And on your environment, so an S3 will have can have a key like specified by your KMS, or you can use the default encryption on the S3 bucket. So a couple cloud threats we're gonna be talking about: misconfigured storage bucket, stolen credentials, publicly exposed services, or lack of MFA. Pretty common attack vectors, not only in cloud but everywhere else. Misconfigured storage buckets more look at like overly permissive actions, publicly exposed services, misconfigured network security groups, or firewalls that aren't necessarily configured properly. So I'm going to be taking a look at one challenge from an intentionally insecure cloud setup. So if I take a look, sorry. Okay, so this is an intentionally insecure cloud setup, and we're going to be going through level 1 right here. This is just going to be, it's called Buckets of Fun, and we're going to be actually exploiting a intentionally insecure bucket. So first step is we want to figure out the IP of flaws.cloud. So if I'm going to actually switch this up. Sweet. Okay. So let's open up a command prompt. Oh, and taking a look, we can also take a look at the hidden directory I was mentioning earlier. It's going to have config, and if you set up your user with that, it's going to have a file specified credentials. So first things first, we want to figure out the IP of flaws.cloud. So we're pinging flaws.cloud. Next step is you want to see if we can visit that IP directly. As you can see right here, it takes you directly to the S3 bucket page. This most likely means that this is a static site hosted in an S3 bucket. So what we can do right now is actually do a reverse lookup of that specific IP that we found. And we can see right here, S3 website US TAC West TAC 2.amazon aws.com. So we figured out from this reverse lookup this this region that we're going to actually want to be messing with. So from here, we can see that there's a bunch of different directories. So if I click on hint1, it takes you to hint1.html. My thinking is that there's probably a hidden page that we need to find by enumerating the S3 bucket. So if we can actually directly interact with this S3 using the AWS CLI, list the contents of that S3 / flaws cloud / tech region. So as you can see here, unable to locate credentials. So we are not able to actually interact with this. However, how many of you guys know about anonymous logins with like file transfer protocol, things of that sort? Awesome. At least a couple of you. So if we add another thing called tag no sign request, we actually can get all of the hidden directories that we may not necessarily find. So as you guys can see, there's hint1, hint2, hint3, and then the index.html. However, there is this secret dd02c7c.html. So why don't we try and visit that guy and see what happens. That is the secret file that we found on the S3 bucket static site. There are multiple levels to this, so you guys can go as far as possible. Going back over a couple of these other intentionally insecure setups, CloudGoat, it's just a GitHub that provides you with a set of challenges that you can complete. Coalfire Research Platform as a Service CloudGoat, it's a Salesforce instance that you can actually intentionally exploit. But other than that, guys, that is all from me today. Anyone have any questions? Okay. Well, that is it for me, but I thank you guys for letting me present today.